with the next speaker. She's Rosa Molina, and she's from the University of Cadiz in Spain. And the title of her presentation is Coastal Characterization and Evolution at a Regional Scale, the case study of the Mediterranean Andalusia, Spain. So please, Rosa, take the floor. Rosa, we can see your screen, but we can't hear you.
Now, yes?
Now it's okay. Yes.
Okay.
Okay. Yeah.
Well, I'm Rosa Molina from the University of Cadiz, and I try to do a brief presentation of my work, because this is the work that I developed for my PhD thesis that I finished last December. I present the work Coastal Characterization and Evolution at a Regional Scale. The case of Mediterranean Andalusia in Spain, south of Spain. As a general introduction, in past decades, coastal erosion-related impacts on the world shorelines have been significantly growing due to the ongoing coastal development and tourist occupation, and the natural erosion and flooding events exacerbated by climatic change. Ocean coastlines are a highly dynamic and changing environment, since they show a great temporal and spatial variability in response to the action of different and complex coastal processes at an interannual time scales related to season and wave climate variation due to temporal and spatial distribution of high latitude storms and tropical storm hurricanes, as a result of events with a large return period, as the impact of very energetic storms and tsunamis, sea level rise, or variation in river sediment samples. In order to prevent and reduce such impacts, coastal managers need to know the sensitivity of natural coastal sector, which is related to wave energy, beach characteristic and evolution, and sea level trend, as well as the potential vulnerability and economic value of the urbanized sectors. The main aim of this work is to evaluate the evolution, the present state, and the condition of beaches and dune systems of the Mediterranean Andalusia. And I use cartography generated and a detailed analysis of wave data. The study area is located at south of Spain. Administratively belongs to Cadiz, Málaga, Granada, and Almería provinces. Has a prevailing rectilinear east-west outline with two northeast, southwest, easterly facing sectors. One near the Gibraltar state, and the other one the Almería easternmost coastal sector. It is a macrotidal environment with a total length of 546 kilometers, including rocky sectors and intermediate to reflective beaches that usually compose of medium to coarse dark sands or pebbles, and the dune systems, which have a total length of 76 kilometers, are especially observed along the province of Cadiz and Almería. The Betic Range is a tectonically active mountain chain that reaches relevant elevation close to the coast, determines coastal orography and morphology, forming cliffs, embankments, and promontories. Several small coastal plains are especially extended at the mouth of short rivers and ramblas, that there are seasonal streams that drain the chain. And in the past decades, river basin regulation plans devoted to water management for tourist and agricultural purposes have enhanced the construction of dams and reservoirs that have reduced sediment supplies to the coast and have promoted coastal retreat in most deltas. Regarding the weather characteristics, the area has a Mediterranean climate with subtropical characteristics in Cadiz, Malaga, and Granada province, and subdesertic characteristics in Almeria province. The coast is generally exposed to winds blowing from east to west and from northeast to southwest in the eastern part of Andalusia, with minimum maximum velocities ranging from 0.4 to 9 meters per second. The wave climate and storm energy are very variable. The coast of Cadiz province is mainly affected by eastern storms. Malaga, Granada, and the west Almeria province are exposed both to western and eastern storms. And East Almeria province is primarily exposed to eastern storms. Waves shows a clear seasonal behavior, with storm conditions being recorded during the winter season. Due to shoreline orientation, predominant easterly winds and associated storm waves give rise to sea wave conditions generating a prevailing westward littoral drift. Meanwhile, an opposite drift is particularly important in certain coastal sectors or periods. Concerning wave climate, these results are published in the paper that I put down the slide. Was characterized along the Mediterranean coast of Andalusia for the period 1979-2014. At the image, you can see the methodology that I worked, and an example of the results that we have obtained. We take a definition of coastal storm to characterize and classify the storms into 5 classes by means of their associated energy flux value. And different behaviors were observed along the coast in terms of energy, number, and duration of storms. And there were recorded 9 storm years that are years with agreed cumulative energy. Regarding coastal evolution and the impacts on coastal structures, an amount of 47 units were defined along the static coast, and evolution rates were quantified for the period 1956-2016 using the disaster extension of ArcGIS software. The methodology used in this work is highlighted in red. You have 2 examples of the results obtained. The first map is an example of the coastal evolution of an unstable beach, and the coastal trend is a little dimension. I don't know if it's see very well. And the other example is the coastal evolution of a modified delta, and given it's a little, very little. Sorry. The results obtained in this work, this is 9 units that recorded accretion, 19 units recorded erosion, and 19 stability. Concerning the beach surface balance, 17 units presented a positive balance and 28 a negative one, and a net negative balance of more than 29 square meters per year. The analysis of coastal evolution evidenced the impact of hard structures. Accretion was essentially observed updrift of ports and groins and in correspondence of breakwaters. Erosion was observed downdrift of ports and groins and in correspondence of seawards and riverments and at larger river deltas. And stability was observed at pocket beaches and coastal areas locally stabilized by protection structures and nourishment works. These results were used to determine the distribution of swatch and drift-aligned coastal sectors and the main direction of the sediment transport. Regarding dune systems evolution, they were mapped different types of dune systems, as well the dune toe position and fermentation. And human occupation and evolution from 1977 to 2001 and from 2001 to 2016. In total, they were delimited 53 dune systems along the Mediterranean coast of Andalusia. Differentiation three types of dune systems. The embryo and mobile dunes was the type 1, grass fixed dunes, the type 2, and stabilized dunes. Here, in this map, you can see an example of a formation of a new dune system. Highlighted in red is the methodology used to do this part of the project. In the 1977-2001 period, it was observed a general decrease in dune surfaces linked to the increase of anthropic occupation and dune fragmentation, especially in Malaga and Almería province. During the 2001-2016 period, smaller changes in the level of fermentation and in dune surface were observed. An increase of dune surfaces was only observed on a stable of Aquitaine Beach throughout the 53 dune systems, both in natural and anthropic areas, usually updrift of ports. In this graph, you can see the results obtained of the surface of the dune systems, differentiating the three types of dunes. The mitigation strategies. In order to determine the mitigation strategy against coastal erosion by taking into account the sensitivity of natural coastal sectors and the potential vulnerability and economic values of the urbanized sectors, there were established three options: no action, adaptation, and protection, according to three steps easily applicable on a regional scale in other areas. These three maps represent three examples of their studied areas, one for each coastal strategy. At first, coastal sensitivity was determined as a function of the distribution of wave energy along the coast and the characteristic of the buffer zone, that is, the dry beach width expressed as a multiple of the 20 years predicted shoreline position. Land use were obtained and classified according to their economic value, and the information concerning coastal sensitivity and land use was crossed to determine the best mitigation strategy to cope with coastal erosion. The results, the three strategies: the no action, that was observed at the westernmost area of Cadiz province and some areas from the west coast of Almería province, where both coastal sensitivity and land use classes show low values. The adaptation option was recorded along more than one half of the coast study, essentially at natural areas with high sensitivity and at urbanized areas with low sensitivity. And the protection option was observed especially at some areas from the center and eastern part of Malaga province and at the easternmost areas of Almería province, where both coastal sensitivity and land use classes presented high values. The main results and conclusions are: in order to prevent and reduce coastal erosion and damages to human structures, it is very important to characterize local sea climate and coastline and dune system evolution, as well as to understand their past and future changes. where climate considerably varies along the Mediterranean coast of Andalusia, from a relatively sheltered area close to the Gibraltar Strait, exclusively affected by easterly storms, to a very energetic central area exposed to both western and eastern storms, and to a low energy area at eastern Almeria province that, because of coastal orientation, is very exposed to eastern and sheltered to western storms. Regarding coastal evolution, the studied coast was divided into 47 units, as I said before. 9 units recorded accretion, 19 recorded stability, and 19 the prevalence of erosive processes. A positive balance was observed in 17 units, meanwhile 28 units recorded a negative balance. Concerning the influence of coastal structure, it was observed that accretion areas were essentially located updrift of ports and groins, and in correspondence of breakwaters. Coastal areas in front of seawalls and riverbed always recorded erosion, which was also relevant downdrift of ports and groins, as well as the mouth of largest rivers and deltas. Stability was observed at several pocket beaches and at areas stabilized by coastal protection structures. About the evolution of the 53 dune systems, all but 4 recorded a reduction of their surface or even disappeared, especially during the 1977-2001 period, when they were affected by hard human intervention and secondary at place by shoreline erosion processes. Dunes loss was linked to the fragmentation of the dune toe, mainly due to the opening of pathways. An increase of dune system surface was observed in both natural and anthropic areas in Cadiz and Almeria province, inactive and stable beaches, usually on the updrift side of ports, or due to strong east winds of the east-facing beaches. Concerning the studied types of dunes during the period 1977-2001, a decrease in the surface of the 3 types of dunes was recorded in most of the province, and in the period 2001-2016, in all provinces except Almeria, there was a decrease in the dunes of types 1 and 3, and an increase of type 2, linked to the degradation of type 3 at very anthropized areas. In Almeria province was recorded an increase of type 3 in stable and active coastal sectors. Concerning mitigation strategies against coastal erosion, were determined according to the sensitivity of natural sectors and the potential vulnerability and economic value of urbanized coastal sectors. The methodology proposed in this research is easily applicable on a regional scale in other areas, and it is of great interest for coastal managers. The 3 proposed options were the no-action option, proposed for areas where both coastal sensitivity and land use classes show low values. The adaptation option was partially linked to the great level of urbanization and the general erosive behavior. And the protection option was proposed for coastal sectors where both coastal sensitivity and land use classes presented high values. In such areas, the implementation of mitigation strategies will be required in future years, and the results obtained in this research on shoreline and dune system evolution can be used to improve existing databases on the characteristics of Andalusia Mediterranean coast, especially of dune systems that in the past have recorded few attention. Such ecosystems have to be maintained and enhanced in order to develop protection functions according to the green engineering philosophy, instead of the traditional approach based on construction of hard defensive structures. Thank you.
Thank you, Rosa, for your presentation and for sharing with us the results of your PhD thesis. Are there any questions for Rosa? No? No? I have Okay, Victoria. Victoria, but we can hear you, Victoria.
Can you?
Okay. Yes.
Okay. Now, I was curious because you described this coastal evolution, and if you have also considered if there is a rule of the sediment supply changes, sediment from supply coming from rivers, if it has changed and how, if you have considered this data and how you have considered it.
We don't have consider this data because we don't have data of the sediment supply rivers, but we consider the data obtained by other works that they studied the sediment samples.
Okay, thanks.
I have a question, Rosa, for you. If nobody has another question, I don't see any reservation on the chat. So I think this kind of approach, this kind of study can be easily exported also for study other coastal areas. So at regional scale, they are very useful for the characterization of coastal sectors. And I was wondering, they are very useful also in the context of climate change adaptation. So I was wondering if you have any data about local sea level change, because you have done a very deep characterization of the present day dynamic and forces affecting the Andalusia, the Mediterranean and Andalusia coast. But do you know if you have data or indication information about future expected sea level?
Yes. With the sea level rise in this area of the Mediterranean, in Andalusia, we don't use the sea level rise data because all of the data the record works says that it's not a good. There's not a significantly sea level rise.
Contribution from other factors, maybe.
Yes, specifically the spot of Tarifa in the Gibraltar Strait recorded not a sea level rise, no. Sorry for my English. A diminution of sea level rise.
Okay. Decrease.
Exactly. A decrease of sea level rise in the spot of Tarifa at the Gibraltar Strait. The other areas, there are insignificant variation of sea level rise.
So, okay. You don't have any particular information for local trend. Okay. So again, I think that this kind of approach can be very useful for the characterization of the coastal areas. So thank you for sharing with us your methodology.
Thank you.
So thank you, Rosa, and congratulations.